So as we think about measures of central tendency, we've learned about mean, median, and mode. And when should each measure of center be used? So this depends in part on the distribution. So recall our normal distribution. It is normal because it is symmetrical. You can see on either side of the line, things look approximately the same. And in a normal distribution, mean will be the same approximately as median, which will be approximately the same as mode. If the distribution is normal, mean is an excellent measure of central tendency. But what if the distribution isn't normal? What if it is a skewed distribution? You'll recall that a skewed distribution has a long tail on one side or the other. That means that in this right skewed distribution, there are a lot of people who have scores in this low region and fewer who have scores in the high end. And the reverse is true in this distribution. We have many, many scores on the high end and fewer scores on the low end. Look at the positioning of mode, median, and mean in these two distributions. You'll see that mode is at the highest point in each distribution. Median, if we lined up all the values, might be a little bit more toward the tail of the distribution, and mean is quite far toward the tail of the distribution. So in general, we can think of skew as having and a skewed distribution might be due to outliers or values that are far from the cluster of values, and we'll look at this in a moment. In this kind of distribution, median is the best measure to use. And you can see that we might think of it as if there are magnets on the tail end of the distribution pulling the mean toward it. The mean always gets pulled into the tail by the higher or lower values that are in that far end of the distribution. And I like this because it's just a good way to remember that the magnet pulls toward the tail and it pulls most firmly on the mean. So in this case, median is going to be a best measure of central tendency. Mode is not useful for statistics. Wait, but why? So we're going to use this as an example of why. Let's imagine that there are a bunch of people selling pies, living in Saley, and they're selling pies for some organization. And JG sold 5 pies, CR sold 7, PQ sold 7, TT sold 6, RV sold 8, JP sold 4, WJ sold 5, KJ sold 6, and SF sold 6. So we have all these people who sold different numbers of pies, and let's imagine that we wanted to create a distribution. If we created a distribution, this is exactly what it would look like. And you can see that it approximates the normal distribution. And in this case, we would find out that the mean is 6, the median is 6, and the mode is 6. So mean is 6, median is 6, mode equals 6. So we could say, you know, kind of on average, or a typical person sold 6 pies, sold around 6 pies. Now let's change the scenario just a little bit. And by the way, if we were going to write that up, we would write, on average, the Saley Rec Group sells 6 pies per week. We'd write M equals 6 here. The most commonly sold number of pies per week is 6, mode equals 6, and the median number of pies is 6. The lowest number was 4, the largest was 8, resulting in a range of 4, and they fell along a normal distribution. So now we'll change the scenario up a little bit. Let's imagine a different rec group, and let's imagine that exactly the same number of pies were sold by the people in this rec group, except they had one person who lived there who was a professional baker who sold many more pies each week than the individual pie makers. And this person sold 16 pies. It's an outlier because it lies far outside the other values. And there it is. Here's the 16 pies, and this is an outlier. Now, let's make a histogram so we have something we can say about them. And we'll do that by just moving all of these into where they belong, the 5 pies, the 7, the 6, the 8, the 4, the 5, the 6, the 7, and let's put that 16 where it goes way up here. So before we had this normal distribution, and now we have most definitely a skewed distribution with this long tail, so we'd say it's a positively skewed distribution, or a right-tailed distribution. So the 16 is the outlier. You can see where it is, and of course this is skewed right. Let's calculate mean, median, and mode with this distribution. First, mode, the tallest bar is still 6, so mode didn't change, mode is 6. Next, median. If we line up the 10 numbers, we can see, even if we put the 16 in there, we can see that the median is also still 6, the number right in the middle. No change. And let's calculate mean. We know last time, without the outlier, the mean was 6. What is it this time? We'll use our formula, the sum of all the scores divided by n. Here's the sum of all the scores, which is 70. If we divide by 10, we find that the mean equals 7, and that this is an increase from example 1. So in this example, then, we had the mode, and we had the median, both staying the same, but mean gets pulled up. Remember, the magnet that we drew in our last picture pulls on the mean. So let's do these again. There's the mean, median, and mode, and the mean line is over here getting pulled toward the tail, while the mode and median are not changed. So now we could say quite a bit different. We would say now that the mean equals 7 and the range equals 12, the distribution was skewed, and in a skewed distribution, the more accurate measure that represents what's actually going on is the median. So to conclude, here are the guidelines for choosing a measure of central tendency. The mean should be used with continuous data when a distribution is normally distributed. This is the most useful tool for inferential statistics, which is what we'll be doing in this class mostly. The median, used with rank-ordered variables, or when a distribution is skewed with one or more outliers. We don't use this in inferential statistics. We stay with the mean, so we're reliant on the normal distribution. And the mode we would use with nominal variables or multimodal distributions, distributions with more than one mode. And again, rarely used in inferential statistics.